Hello, welcome to 6.2. Today we're going to learn about kites, trapezoids, and midsegments. By the end of the day, you should say, I can describe and use the properties of kites and trapezoids. All right, now we'll go through, those are the answers for the previous day's stuff. We don't need to see that right now. All right, a kite is a quadrilateral where it has two sets of congruent sides. And these congruent sides are going to be consecutive. So they're going to be two in a row and two in a row. All right, so now that we have vertex angles and non-vertex angles. The vertex angles are the angles between the two congruent sides, and then the non-vertex are the other two. Now, some people get fooled by this picture when the kite is now on its side like this. Now remember, the vertex angle is between the two congruent sides, so that would be a vertex angle, and that would be a vertex. So these two would be non-vertex. All right, now if we look at a kite, I'll start this up again. So a kite, there's two ways to make a kite. One way is to start with a point, and we can construct a kite by going out to these 2 points, because we know those two have to be congruent. And then we would have to have a length of this third one. So maybe if I just had this length here, if I took a circle and took that length, and now now brought that over, not the whole thing. If we bring that whole thing here, now if I copy and paste that again, I'm going to put another one of those circles on the other vertex. So where those two circles intersect is going to be the fourth point of our kite. It's going to be right there, and from there, back there. And now this is a kite where these two sides are parallel, or congruent, and these two sides are congruent. All right, now there's another way we can look at kites as far as constructing them, and that's if we want to start with diagonals. So if I start with a segment here, and that's one diagonal. Now a kite, if I take the midpoint of that, undo, redo. So if I take the midpoint of this line, which is C, and now I draw a perpendicular line through there, now we can connect these, and those two are congruent. If I connect this one and now to A, now this is another way we can get a kite where these two are congruent and these two sides are congruent. Now if we take a look at this kite, there's certain things that are going to be true. One is that this angle, this full angle A and full angle B, is always going to be the same measure. If I move D up, that's increasing both of those angles at the same rate. Or same if I'm moving it down, it's decreasing it. Also, these diagonals will meet at 90 degrees. And that's going to cut this in half. So the diagonal going through the vertex angle is the perpendicular bisector of the other diagonal. Now, the last thing is that these are also angle bisectors. So, and that's just on the side of the vertex angles. The non-vertex angles are not angle bisectors because I could move this D down and that changes the top angle but not the bottom angle. All right. Oops, wrong one. So if we look at this, here are the rules for a kite. The diagonals of a kite are perpendicular. The diagonals connecting the vertex angles of a kite are perpendicular bisector of the other diagonal. The non-vertex angles are congruent, and the vertex angles are bisected by the diagonal. All right, so now if we look at some of these properties, if BD is 10, then BE and ED are each going to be 5, because we know that it's bisected. If we know 50 and 30, we want to find x and y. If this is 30, this side over here has to be 30, so those add up to 80, so x has to be 100. These are vertex angles, or non-vertex angles, so those are going to be congruent, so that's 100. On this one, the trick on this one is to know that these cross at 90 degrees, and if that's the case, these all add up to 180, so 180 minus 90 minus 34 is going to be 56, and this is an angle bisector, so B is 56, and C would then be 34. Down here, this is 22 and 90, so this is going to be 68, because 90 plus 22 subtract from 180 is 68. Now if we have diagonals 4 centimeters and 6 centimeters, you draw this out about 4 centimeters, go halfway, and that's going to be 2 centimeters, so 2 and 2. Now we just draw the perpendicular bisector and make that 6 centimeters long. So now once we have the diagonals, now we can draw the sides, and we have a nice, wonderful kite. All right, now our next quadrilateral we're going to look at is a trapezoid. A trapezoid looks something like this. But a trapezoid could also look like that. If I pull this back. Now, the definition of a trapezoid is it has exactly one pair of parallel lines. So see how these are parallel? So that means that this is a trapezoid. But the more traditional trapezoid looks like this. And these are parallel. So what we need to figure out or see in a trapezoid are these two angles will always add up to 180. That's x and y. So x plus y equals 180. So our rule is the consecutive angles of a trapezoid are supplementary. And remember, supplementary means adds up to 180 degrees. Now, if we want an isosceles trapezoid, so if we wanted to draw an isosceles trapezoid, it looks something like this, where these two sides are going to be congruent. Now, if that's true, these two angles are going to be congruent. And with the previous thing, tells us that these two things have to be congruent. So an isosceles triangle, the base angles are going to be congruent. Also, if we drew the diagonals, this diagonal is going to be exactly the same length as that diagonal. So those are our properties for isosceles trapezoid. The base angles of an isosceles trapezoid are congruent, and the diagonals of an isosceles trapezoid are congruent. All right, so now let's find the degree measures. Now, between bases, these two angles will add up to 180. So 180 minus 62 is 118. 180 minus 70 is 110. Now, if this is an isosceles trapezoid, so if this is 65, this has to be 65. And then up here, subtract from 180 to get 115 and 115. All right, a segment connecting the midpoints of a triangle is called a midsegment. So if I have the midpoint of this side and the midpoint of this side, connecting them would be the midsegment. Now this midsegment is going to be parallel with these two sides, and it's also going to be congruent with, or so it's not congruent, but it's half of the full length down there. So here is our conjecture. Actually, it's this one. The midsegment of a triangle is parallel to the third side and half the length of that third side. And that's what I showed here. So if this side is 8, the whole one down here is going to be 16. Now if I took this one and made, it's more like there, made the midpoint of the third side like that, these three triangles, 1, 2, 3, are all going to be congruent. And this one here is also going to be congruent, but it's this top one flipped over. So the three midsegments of a triangle divide the triangle into 4 congruent triangles. All right. Now there's also a midsegment in a trapezoid. A segment connecting the midpoints of two non-parallel sides of a trapezoid is called a midsegment. So if I connect this point and this point, those I'll call a midsegment. Now hopefully you can see that they're all parallel, but now it's not going to be half, but it's going to be the average of the two bases. So the midsegment of a trapezoid is parallel to the bases and equal in length to the average of the two base lengths. So now let's do some problems. Let's find the missing pieces. If I have 62 and 48, W makes the third angle in this big triangle. So that adds up to 110, so W has to be 70. Now this triangle is going to be the same as this triangle, so this is going to be 70. And this triangle is the same as this one, so this one has to be 48. So even though it doesn't tell us, we could fill in all these angles, 62, 48, 70, 62. However, this triangle is the triangle on top flipped over. So 62 would be down there, and 48 and 70. It's actually not flipped, it's rotated around some point in here to get it to land even perfectly. All right, now for side lengths, if this is 6, this has to be 6, and 15, and 10. So this midsegment is the same length as this, so that's 10, 15, and 6. All right, if I know the top and the bottom bases to find the midsegment length, I have to add them up to get 16, divide by 2, and I get 8. So that's going to be 8. This next one, pause the video and see if you can do it on your own. All right, 34 plus 52, that's going to be 86. Divide that by 2, and you'll have 43. All right. Now this one, I want to look back at this property. Hopefully you can see that there's 11, the distance between 34 and 43, and 11 between 43 and 52. So here, if this distance is 14, then you have to go 14 back to get this top value, which is B20. We can do the same thing here. We go up 6 to get to 28. If you go back 6, that'll get you down to 14. All right, hopefully that is enough to get you through the homework. Good luck.